Roughly 100 years ago, in 1908, a species of virus present only in chimpanzees, known collectively as SIV, jumped across the species barrier and infected its first human victim. Through decades of transmission and mutation, it has evolved into what we know today as HIV. Today, over 36 million people in the world are living with HIV. One notable case was Timothy Ray Brown, who was diagnosed with HIV back in 1995. After his developed acute myeloid leukemia relapse, he received one life-saving bone marrow transplant, which cured him of both HIV and leukemia. And to this day, he remains the only person in this world to be fully cured of HIV. Let's dive in deeper. Human immunodeficiency virus is a retrovirus that targets a human being's T helper cells, which are responsible for initiating an active immune response to pathogens by activating T killer cells, which attack intruders, and B cells, which release antibodies that also join the fight. For HIV viral entry to happen, an envelope called GP120 needs to wrap around a glycoprotein called CD4, but HIV requires another co-receptor to enter the cell. There are three cases. HIV either needs to also bind to a protein called CCR5, a protein called CXCR4, or both. Thus, HIV can be separated into three types, or tropics: N-tropic R5 strains, T-tropic X4 strains, or dual-tropic R5X4 strains. After viral entry into the cell, an enzyme called reverse transcriptase is used to convert two single-stranded HIV RNA into DNA, which is then fused with the cell's original DNA using the enzyme integrase. The cell then makes and releases many new copies of HIV before eventually dying off. Once HIV has killed off enough T helper cells, you develop AIDS, having your body's defenses rendered useless, and are vulnerable to opportunistic infections caused by pathogens that someone with a healthy immune system can fight off relatively easily. HIV can mutate really easily to resist one type of drug, so current treatment consists of a cocktail of drugs which target different periods of HIV virus's lifetime. However, there still is no cure available. But some people have a rare genetic mutation called CCR5 delta 32, which causes them to have less CCR5 on their T cell surfaces. Two copies of this mutation, occurring in only 1% of all Caucasians, would mean no CCR5 at all, and thus immunity to N-tropic and dual-tropic strains of HIV, which require CCR5 for viral entry and account for over 90% of all HIV. This genetic mutation is extremely rare and occurs mostly in Northern Europe, West Asia, and Central Africa. Timothy's bone marrow transplant donor just so happened to have this double mutation, and as a result, Timothy's new T helper cells were immune to HIV virions, leading to a complete remission of HIV. Sadly, Timothy's life-saving procedures can't be applied to other HIV patients, but research in CCR5 have led to new hope for a cure. Already, experimental solutions which aim to modify our T helper cells to make them CCR5 negative are going under clinical trial. There's even been talk of using CRISPR-Cas9, a programmable gene editing tool, to edit the DNA which dictates the presence of CCR5, located in the third pair of our human chromosomes. While there's still many challenges to overcome in this type of approach, Timothy Ray Brown is living evidence that hopefully one day more people will be able to say, "I once had HIV."